Let us now examine the behavior of water below 4 degrees Celsius. Now, when most liquids are heated, those liquids will expand. However, unlike most liquids, when water is heated from 0 degrees Celsius to 4 degrees Celsius, it actually contracts. So the opposite happens. The volume doesn't get larger, the volume becomes smaller and the water becomes more dense. Now, above 4 degrees Celsius, if we heat our water above 4 degrees Celsius, the water will behave normally and it will expand. So, for example, when we heat our water from 4 degrees Celsius to 10 degrees Celsius, the water will expand. But when we heat it from 4 degrees Celsius or from 0 degrees Celsius to 4 degrees Celsius, the water will contract. The opposite will take place. So let's examine why that actually happens. Why does our water contract when it goes from 0 degrees Celsius to 4 degrees Celsius? Let's suppose we have the following container and we have water inside the container in the liquid state. And the temperature of the water is 0 degrees Celsius. Now, if we zoom in onto the microscopic level, if we take a small area and we zoom in, we'll see the following results. So we'll see a bunch of water molecules moving about and vibrating in place. Now, if we move to diagram B, if we take a flame and heat our container of water from 0 degrees Celsius to 4 degrees Celsius, and then we zoom in onto the microscopic level, we'll see that the water molecules actually move closer together. So, they're still moving about and they're vibrating, but each molecule is closer to the other molecule. And collectively, because the molecules are closer to one another, what happens is the entire volume of our fluid, our water, will contract. So this level will drop. It will lower. So once again, when water is heated from 0 degrees Celsius to 4 degrees Celsius, the water molecules get closer and water becomes more dense. So as a result, water is most dense at 4 degrees Celsius. So if we take this water at 4 degrees Celsius and this water at 0 degrees Celsius and we mix them, the water at 0 degrees Celsius, the less dense water will stay on top, and the more dense water, the water at 4 degrees Celsius, will move to the bottom. And this result creates biological implications, as we'll see in just a moment. So, most solid objects are more dense than their liquid counterparts. And so, if, for example, I take a certain solid object and place it into its liquid counterpart, that solid object will sink. On the other hand, unlike most solid objects, when water is frozen into its solid state, it will expand and will become less dense. And that's exactly why when you take an ice cube and you place it into water, that ice cube will float. It floats because it's less dense than the liquid counterpart. So, let's examine the microscopic level of our solid water. So if we zoom in onto the microscopic level of solid water, we'll see a crystal lattice shape. So we'll see that our water molecules are fixed in rigid positions and they vibrate back and forth. Now, what happens when we heat our solid water, when we heat ice and it melts into liquid, the water molecules will actually move closer together because they will no longer be in fixed positions, and so they can actually move closer. So, we see that when we go from solid to liquid, water becomes more dense. When we go from liquid to solid, water becomes less dense, and that's exactly why ice floats on liquid water. Now, let's examine a very important biological implication of this property, of this behavior of water between the range of 0 degrees Celsius and 4 degrees Celsius. And let's examine the following lake. So let's suppose we have the ground and we have a lake. So when the water inside the lake is above 4 degrees Celsius and begins to cool, let's say in the winter, the water on the surface sinks to the bottom. So that's because we said above 4 degrees Celsius, water behaves normally and will expand. In other words, as you increase the temperature of water above 4 degrees Celsius, it becomes less dense. And as you decrease the temperature above 4 degrees Celsius, it becomes more dense. So that means the cooler water will sink to the bottom. Now, let's move on to diagram B. So what will happen is there will be a mixing of this cooler water and the warmer water, and the mixing of water will continue until the water reaches 4 degrees Celsius. Now, as the water cools further at the surface, it will remain at the surface because remember, when water is at 4 degrees Celsius, it is most dense. So the water at 4 degrees Celsius will will drop to the bottom, but the cooler water will remain on the top. Now, this will continue until the water at the top reaches 0 degrees Celsius, and then it will freeze over and ice will form on the surface. But at the bottom of the lake, the water will still be at 4 degrees Celsius. And this is very important because this means that the layer of ice will act as an insulation layer. And that basically means that all the different organisms and all the different fish found beneath the ice will survive the winter months because the ice will insulate the water at the bottom, and so the fish won't actually freeze over. Now, of course, if the temperatures are very, very low, or if the lake is very, very shallow, the entire lake can potentially freeze. And if that takes place, the fish and organisms will die. So we see that water, or the behavior of water, creates very important biological implications. In fact, if water did not have this type of behavior, life would not exist in the way that we know it today.